Hey guys, so we ended up skipping Unit 5 and eliminating it completely, and instead we're moving on to Unit 6. And Unit 6 is kind of a review of Algebra 1 because it's all about exponents. So in the first one, we have Introduction to the Product Rule of Exponents. So the product rule of exponents says this. Product rule says that if you have a to a number n times a to a number m, then so in other words, if you're multiplying two of the same variables raised to a power, then what you are going to do with those powers is you are going to add them. Okay, so your answer is going to be whatever the variable was, a, to whatever n plus m was. Okay, that is the rule for product. That is the product rule for when it comes to exponents. So in the first example, we have w to the fourth times w to the second. They are the same exact um, letter and same exact variable. So all we're going to do is add those powers. So it becomes w to the 4 plus 2, which is w to the 6 power. Okay. In the next example, we have d to the fifth times d. And remember, if there is no number showing, then there is always a power of 1 there. So this becomes d to the 5 plus 1, which is d to the 6 power. And that's how that one looks. In the next example, we're going to use the product rule with positive exponents and with numbers out front. So we have coefficients now, okay? So what you're going to do is your first step in all of these is going to be to multiply the coefficients, which is just the numbers out front of the variable. Sorry, I ended up spelling that wrong. So it's just the numbers outside of the variable there, coefficients. Okay, so that's our first step. So in the first one, we have 9 and negative 3 are her numbers out front. So 9 times negative 3 is negative 27. And then what we're going to do is we're going to apply the product rule that we just learned about in the last one to add these exponents because we are multiplying. So then our second part of our answer is x right next to the negative 27 to the 1. Remember, if there isn't any variable, if there isn't any exponent showing, then there's a 1 there. 1 plus 8, which is 9. So our final answer there would be negative 27 x to the ninth power. In the next one, the coefficients out front are negative 5 and negative 1, right? There's an imaginary 1 there if it's not showing up. So negative 5 times negative 1 is equal to positive 5. There's our number out front. Now we are going to multiply using the product rule the y's, or the variables. So we have y to the fourth and y to the fourth. And what we're going to do is we're going to add those exponents. So it becomes y to the eighth. There's our final answer for that one. 5y to the eighth power. And then we just get a little more, a little more complicated and just add one more variable to work with, or not even one more variable sometimes, but another term to work with. So pay attention to the steps because we're definitely going to always multiply the coefficients first. So the coefficients in this one are 4 times 3 times 2. Those are the numbers out front. And 4 times 3 times 2 is 24. So we did that part. Then what we want to do is we want to make sure we only combine the variables that are the same letter. So notice I have a W and a U in here. So I'm going to combine the W's first. So I have W to the 6th and W to the 8th, and I'm just going to add those powers to get W and put it right next to the 24 to the 14th power. 8 plus 6 is 14. Okay? And then from there, I'm going to do the last part. And the last part is that I have U to the first power and U to the 7th power. So I'm going to write that as U to the 7 plus 1, which is 8. So our final answer is going to have 3 terms in it. The number out front, the coefficient, the W, and the U. All right, so let's look at another example of that over here. In this example, we have that the coefficients, or the numbers out front that we're going to do first, are 4 times 5 times 2. So 4 times 5 times 2 is 40. There's our first answer. Then I have some y's and x's, so I'm going to do the y's first. I have y to the 8th, and then just y to the first power. So that is going to produce y to the 8 plus 1, which is 9. And in the last one, I have x's in here, so I have x to the 9th, and then another x to the 9th, and if I add those powers, it becomes x to the 18th power. There's our final answer. Okay, so take these one step at a time, otherwise you might make a numerical mistake here. In the next part, it's asking for the degree and leading coefficient of a polynomial. So it's important to note that the degree of a polynomial is the highest exponent of the variable, okay? And then the leading coefficient of a polynomial is the number out front of the variable with the highest exponent. So first what you want to do is you want to find the degree so that you can find the leading coefficient, okay? So this is pretty easy. This is just looking at a polynomial and deciding what is the degree and what is the leading coefficient. Okay, so degree in this first one is, okay, what is the exponent or what is the variable with the highest exponent? It happens to be x to the 8th power. So the degree of this polynomial is 8. Okay. And then the leading coefficient of this polynomial is what is out front of that x to the 8th power. And the number that's out front of there, even though it doesn't look like it is a number, is in fact -1. So our degree is 8 and our leading coefficient is -1. That's all you need to put for these. In the next one, let's look to see which one is our highest exponent to be our degree of our polynomial. So the highest exponent here is this, y to the 8th power. So that tells me that my degree of this polynomial is also 8, like in the previous one. And my leading coefficient here is what is out front of that variable. So notice that we're going to take everything that's out front of that variable, and that is a -23. Okay, that is all you do for those ones. And then lastly, we have that you can, a reminder, you can add and subtract like terms, which means that they must have the same variable. So in order to be a like term, they must have the same variable with the same power. Or, in other words, since we're talking about these, exponents. So if they have the same exact exponent and the same variable, then you can combine them. So examples of same exponents raised to the same variable are 3 to the x minus 2 is the same or a like term as -x to the second power. So you need to remember that when you are going to simplify with the sum or difference here. So in the first example, we're asked to simplify this as much as possible, okay? So in order to do that, we have to make sure that we combine like terms. We need to find like terms. So in my first term, I have v squared. Is there anything like v squared? Yes, there is. There is a -5v squared. So I'm going to combine those just by simply adding or subtracting. So remember, if there's nothing out front of the v, there is a 1 there. So 1 minus 5 is -4v squared, and we keep the v squared with it. There's your first term. Now, if we look at the next term, we have a -6v, and then we also have a plus 7v, okay? They're the same variable raised to the same power. So if we combine those, we have -6 plus 7, which is 1v, or just v. So I'm going to write a plus v in my answer. And then the last part, we have a +4 and a +3. So if I just add those together, I get +7. Then our final answer looks like this: -4v squared plus 1v plus 7. That's how we have to write our answer. Now, this is an addition problem. That makes it a little bit easier on you. In the second example, we actually have a subtraction problem. So there is one thing you have to do first when you see the subtraction, and that is you have to make sure that you apply that minus symbol to all 3 pieces inside the second set of parentheses. So what I'm going to do is I'm going to rewrite my equation to be 2v squared plus v plus 3 minus 7v squared minus 5v, because I applied the negative to it, minus 4. And that's how our new equation is going to look when I combine like terms. Okay? Now that I have done that, because I noticed the negative sign, now I can combine like terms. So I have 2v to the second. There is another v to the second, and it's over here, and it's actually a negative or minus 7v to the second. So 2 minus 7 is negative 5v to the second power. The next like term that I have is a positive v minus 5v. So 1 minus 5 is negative 4v. And there's my second term. And then the last like terms that I have are a positive 3 minus 4. So 3 minus 4 is negative 1. So our final answer would be negative 5v squared minus 4v minus 1. Okay? And then, of course, we take it one step further and we add in 3 different polynomials to add or subtract. But again, notice right off the back when you are working with these that you have to notice or recognize the negative symbol because that needs to be applied first. So remember that negative applies to all 3 pieces in the parentheses that come after it. So what I'm going to do is I'm going to rewrite my whole equation. So I have 6y squared minus y plus 3. Now I'm going to apply the negative. So it's minus 5y squared. A negative times a negative on the inside for the 4y becomes a plus 4y. And then a negative times a negative on the 1, it becomes a plus 1. Okay? And then I'm just going to add the rest of my equation here. Plus 4y squared, whoops, minus 3y minus 6. Now my equation is good to go. So this is a long equation, so you have to make sure that you figure out what your like terms are so that you can combine them as you go. So I've got 6y squared is like minus 5y squared, and it's also like plus 4y squared. So 6 minus 5 is 1, and 1 plus 4 is 5. So our first term would be 5y squared. The next like terms that I have are a negative 1y plus 4y minus 3y. So negative 1 plus 4 is 3y, and 3y minus 3y is 0. So the y's are actually eliminated from my final answer, the single y's. And then if I combine my last term, which are the numbers, I have positive 3 plus 1 minus 6. So 3 plus 1 is 4. 4 minus 6 is negative 2. So our final answer here is 5y squared minus 2. So make sure you pay attention to your like terms and be able to pay attention to the subtraction sign so that you can apply it to everything that is inside of the parentheses. As always, let me know if you have any questions. Good luck.